You see it everywhere, right? Especially during election season. Every poll has that little disclaimer, margin of error. But what does that number actually mean? Well, we're going to dive in, because there's a really good chance you've been reading the story all wrong.
All right, let's just jump right into it with a classic scenario. You see a headline like this. Candidate A is at 52%, candidate B is at 48%. That's a 4-point lead. The margin of error is plus or minus 3%. So who's winning? Just gut reaction, what do you think?
Now, if your brain immediately went, well, 4 points is bigger than 3 points, so candidate A is winning, you're not alone. That feels like common sense. But, and this is a big but, it's not nearly that simple. That gut reaction is actually one of the biggest misunderstandings in all of statistics. And hey, don't feel bad if this stuff feels confusing. There was a famous study where they gave a simple problem about a confidence interval to a bunch of actual researchers and students, and a shocking number of them got it wrong. So if even the experts get tripped up, you know this is trickier than it looks. So to really solve our poll problem, we have to get the fundamentals down first. Let's start with that term itself, margin of error. What is it, really? The first thing to get is that the margin of error does not mean the pollster made a mistake. It's not an error in that sense. It's really a measure of precision that exists for one simple reason. We're only talking to a sample of people, not every single person in the country. The margin of error just tells you how much uncertainty comes with that guesswork.
Okay, so that margin of error is used to build something called a confidence interval. And this is where the big catch is. This is the idea that confuses almost everyone.
So let's go back to our poll. Candidate A is at 52%, with a margin of error of plus or minus 3%. That gives us a confidence interval of 49% to 55%. Simple enough, right? But what does that range, that 49 to 55, actually tell us? Here it is. The common mistake is saying there's a 95% chance the real number is somewhere between 49 and 55. It feels right, but it's technically wrong. The correct way to think about it is about the process. It means if we did the same poll 100 different times, we'd expect the true answer to be inside our calculated range in 95 of those 100 polls. It's a subtle difference, but it's about trusting the method, not any single result.
Okay, now that we have that foundation, let's circle all the way back to our big question. We have two candidates. We have a 4-point lead. How do we know if that lead is real, or if it's just statistical noise?
We've already figured out that just comparing the 4-point lead to the 3-point margin of error is the wrong way to go. So, what's the right way? How do you actually check if the difference between two candidates means anything? Here's the key, the one big shortcut you need to remember. When you're comparing two candidates in a poll, you can't just use the margin of error they give you. You have to double it. That's right, because think about it. When you're looking at the gap between two people, the uncertainty gets bigger. Candidate A's number might be a little too high just by chance, while candidate B's number might be a little too low. So the potential error for the gap between them actually compounds. It's roughly twice as big. Let's walk through it. The margin of error for one candidate is plus or minus 3 points. Step 2. We double that to get the margin of error for the difference, which is about plus or minus 6 points. Step 3. The actual lead we see is only 4 points. And since 4 is less than 6, we have our answer. The lead is within the margin of error. It's what we call a statistical tie. So that plus or minus 3% number, it's not magic. It isn't always the same. There are a few key things that can make that margin of error, that range of uncertainty, either bigger or smaller. Let's take a look. Okay, 3 big things matter. The first is sample size. Super simple. The fewer people you poll, the bigger your margin of error is going to be. Second is confidence level. If you want to be more sure, say 99% confident instead of 95%, you need a wider range to be safe. And third, and this one is so important, is when you start looking at subgroups. Just look at this real-world example from a Pew Research analysis. For the whole poll, with over 1,000 people, the margin of error is a nice, small 3%. But now look what happens when you slice out just one group from that poll. In this case, the 160 Hispanic voters. All of a sudden, the margin of error explodes to 8%. That is a huge difference in precision, and it's all because the sample size for that one group got so much smaller. So, what's the bottom line here? The next time you see a poll pop up in a news article, how can you be a smarter, more critical reader of that information? Here are 4 rules to keep in your back pocket. Number 1, remember the doubling rule. A lead is just noise unless it's bigger than twice the margin of error. Number 2, a single poll is just a snapshot in time. Look for the trend across lots of different polls. 3,
If you see a stat about a small subgroup, be extra skeptical. The margin of error for that group is probably huge. And finally, and this is crucial, remember that margin of error only accounts for sampling. It doesn't account for other potential problems, like a poorly worded question or a biased sample.
At the end of the day, being smart about data just means being curious and asking the right questions. We've just pulled back the curtain on one little number, but it shows that underneath every simple statistic, there's a whole world of complexity. So the real question is, what other data in your life deserves a second look?